Graphene is not only the basic material of carbon nanotubes, but it's actually what graphite's made out of. Graphite's made out of sheets of graphene, and graphene are just layers of graphite or single layers of carbon arranged in a honeycomb lattice. And if you stack them together, you get graphite, ordinary graphite. Well, that was known, I think, even in the 1800s already. People knew about graphene. It had been heavily studied in many different disciplines, and surface scientists knew about it, chemists knew about it, but nobody had actually thought that this stuff might be good for electronics. And so in 2001, we basically came to the idea that maybe graphene could be used for electronics, and that's how the whole story started, really. The most important attributes are that it's relatively easy to make the stuff. That's a very important thing. The second is that it turns out that electronically it turns out to be a very good kind of graphene. In other words, you can make it over huge areas, covering large surfaces relatively easily, and its electrical properties are very good. It conducts electricity very well. So that is, it actually has this ballistic transport property that carbon nanotubes have, that same property we were looking for and thought graphene might have. In fact, we do find it on graphene on silicon carbide as well. But probably its most important attribute is that you can use it, that the semiconductor industry knows exactly what to do with it, because it fits their model of electronics. In other words, you have a flat layer, and then they can do all their processing techniques on this flat layer of graphene, as they've been doing for the last 50 years to make electronics. Most electronics is based on silicon, and silicon is a material that all the transistors and everything in your computer is basically made out of. Now, it's been known for years that silicon has its limitations, and one limitation is that you can't make the transistors any smaller on the silicon chip, and making smaller transistors is a good thing. Another limitation is that your computer heats up a lot. You might know that it gets pretty toasty, and that's because that's again a problem with silicon. There's resistances involved in the silicon. And there's other problems like that. Well, graphene can actually overcome those problems. It can carry current with less heat formation, and you can make the devices much smaller than you can make with silicon. And so those are two key parameters that ultimately allow you to make smaller and faster electronics. And from that point of view, it can do things that silicon cannot do. There are many, many things that are possible with graphene that are not possible with silicon. You can connect it to biological molecules, for example. You can interface it with something called molecular electronics, a whole bunch of stuff like that. So I think we're looking at a whole new landscape opening up in electronics.